Hey everybody, welcome back to Grade 11 Computers. Today I wanted to look at a smarter array. And so I've opened up a SFML project here, and I'm going to include a library called vector. Okay, and what a vector is it's just a smarter way of using arrays in C++. I talked about I'm just going to comment all of this code out for now, but I will use it later. How do you comment again? Control Shift C? Oh, it doesn't work. Edit, comment. I did press Control Shift C. I don't think my Shift key works anymore. Okay, so we talked about arrays in the past, a lab or two ago, where we would make, let's say, grades or something like that, and then we wanted 12 of them or something. And that was good, except the problem is we needed to know how many students were in the class, and we needed to know before our program ran. The other thing is if a student drops or a student gets added, we're unable to kind of go into the memory of grades and ask for more. And we're unable to delete anything out of it. So arrays were useful for us if we want, especially basically to minimize how much code we have to write. We don't have to make 25 variables. We could just make one and say we're going to stuff 25 things into it. But it had some limitations there where we weren't allowed to add stuff to it. We weren't allowed to erase stuff to it. And so there is a better way to do it. And the way to do it, so where's my float grades there? Sorry. For some reason. Okay, there it is. What you do is you write the word vector, okay, and this is called a container, okay, and there's a bunch of them in C++. The one I only use in computers in high school is called a vector. It's kind of got a bad name. I would have rather it had a name called like list or something like that. And there is one called list. But vector, and they all have different advantages and disadvantages for advanced coders who want more control of memory access and speed. And so there's a bunch of them. You can read about it in the lab. Vector, I think, is kind of the all-arounder for us. It's kind of middle of the road for speed, middle of the road for random access, middle of the road for those kinds of things. So what you do is you write the word vector, and then in pointy brackets you write the type that you want that vector to hold. So it's a little bit of a different syntax from arrays, where you would just write the type like a normal variable, and then write your name, and then write the number. And here I would write grades like that. I already have a grades variable, so I got to go and delete that. And if I want to add 12 of them, I just write in round brackets, I write the number 12 like that. Okay, and that runs. And if I want to say something like grades 0 equals whatever, I can still do it. From there on out, it's exactly like an array for the most part, as far as adding stuff to it. Okay, so I can just go and add stuff like that if I want. And la-di-da-di-da, you'd probably be saying right now, isn't this thing exactly the same as an array? And it is in this instance, but I'm going to get rid of this 12, okay? Because let's say I don't know how many grades I have at the beginning of my program, and I want to add grades as I go along. Well, there's a way to do that. If I write the word grades and hit dot, you could see all of the things I can do with this vector. Okay? There's some repeating in the function names, but there's one called clear. There's one called assign. There's a function called insert. There's a function called pushback. This is the one I like. And what you put in the brackets is what you want to add to the back of your vector. So originally I had vector 0. Right now my vector is empty. Okay. And here I'm going to push back the number 3.14. So let's see what this looks like if I hit debug. Okay, so if you see here, there's a grades variable, but it says it's a vector of length 0 and capacity 0. Capacity is like how much memory the computer's kind of got earmarked for this vector later on. And right now it's decided there's nothing in it, so it's just a vector of length 0. If I step to the next line, you can see now that my vector has a length of 1. Okay, and it's 3.14 with a little bit of rounding issue there, but that's okay. It's added this number to the back of our vector. Okay, so basically we're just tacking on that value. If I want to go and add another grade at some point later on, push back, and then let's say 5 point. Now I don't put the number in quotes like that because that's a string, right? That'll probably crash. Yeah. So I've added another number on the fly, and so this pushback command would get used in a for loop or something like that, and then you could add as many grades as you want. Grades dot pushback. Okay, and then one more number. So let me debug that again. Right now my grades is at a length of 0. I'll step through. You'll see that grades has now one element, that's 3.14. Now I've added to the back of that 5.7, and then on my next line I've added. So now grades is length 3. The capacity, don't worry about that, but the computer is deciding how much memory it wants to keep open for if it thinks you're going to add more to your vector. And so your vector is of length 3. Now this was another thing that was problematic about arrays. We could never figure out what the size was unless we knew it, right? So if I wanted to, let's say I made an array with 12 grades in it, but I only added like 6. How would I know that I only have 6 in there? And so that was another thing about plain arrays that was not very useful. But grades here, just like the string object, has a size command. Okay, so that will output. So now you know how big your vector is at any given time, which is obviously going to be very useful. And it says the number 3 there. Okay. Okay, so that's going to be super useful for us later on, especially in graphics when we need to be constantly adding stuff to our program. So let's make a program where stuff drops from the screen periodically. Okay. So I'm going to get rid of my circle shape like that. I don't need that one. And I'll just comment that out for now. And I'm going to make a vector. You can make a vector of any kind of object that you want. So I'm going to make a vector of rectangle shapes. Okay. And I'll call it boxes. Something like that should be fine. Right now it has nothing in it. Okay. And what I want to do is, there is something in the lab that wants you to make a box at the top of your screen every 10 frames. Okay, so the first thing I'll need to do is make a frame number. Notice how I'm making these variables outside of my while loop. This while loop is going to run 60 times a second. So I don't want to make a variable 60 times a second. That's a very inefficient thing to do. So a lot of my variables should get made outside of the while loop. In fact, most of them should. Okay, so inside of this while loop, I'm going to make frame num go up ++, and then you should be able to see it climb about 60 times a second. Why 60? Because I've set the frame limit. Windows SML actually slows this loop down to 60 times a second. Watch. See that? It's running about 60 times a second. If I get rid of this set frame limit, it'll run as fast as it possibly can, and it'll be really, really fast because it's not drawing anything. Okay, it's much, much faster. It's much more than 60 frames a second. That's probably like 1,000 frames a second or something. That's good FPS. We need to get a monitor with 1,000 hertz monitor. Okay? Look into that for me. Okay, so what we want to do now is add a box to our vector, which has none in it right now, every 10 frames. So here's how you do something every 10 frames. I'll say if frame num %10 equals 0. That's remainder. So if frame num is 10, 20, 30, 40, 50, 60, 70, any number that divides evenly by 10, then this code will get triggered. So I'm going to take boxes here, okay? I'll just write here maybe every 10 frames, something like that. I'll say boxes dot push back. I want to add something to my vector, and I have to write the word rectangle shape like that. And one of the things you actually have to do is write empty brackets, okay, after the word rectangle shape, because when you're pushing back a new rectangle shape, it needs this. If I just do the without the two brackets, it'll crash, and there's reasons for that we'll learn about later. So it does need empty brackets, okay? And it doesn't do anything because I haven't told it to draw anything, first of all. And second of all, I haven't given my rectangle shapes really any properties. So now what I can do is I want to be able to access the one I just added to my vector. So there's a command called boxes.back, okay? And that's basically saying take the one at the back of your vector. And the one at the back of the vector is the one I just pushed back there. And then if I hit dot, I can see that I can do anything I want to that rectangle shape. So what I'll do is I'll set it to a size, okay? And it says it needs a vector 2f, so I'll just write vector 2f like that, and then I obviously need to give it two numbers. I'll say 40 and 40, something like that. Okay, and that's good. That's all I need to do. I also need to draw the everything. So if I run it now, it won't do anything, but I should, if I see out boxes.size, I should see my vector is getting bigger. Yeah, it is there. Okay, I already have 20, 30 of them in that vector. They're just not drawing yet. So I have to make a draw command, but I'm going to have to do that inside of a for loop because sometimes I'll have 1, sometimes I'll have 2, sometimes I'll have 3, whatever, right? Int I equals 0, and here I'll go boxes dot size like that. Okay, so then my for loop's going to run from 0 through to the size of the vector. And then I'll go window dot draw, and I will write boxes I. Okay, boxes I meaning, remember it acts like an array, right? Vectors can still be called the same way an array is. So when I is 0, it's just drawing the first one, and when I is 1, it's drawing the second box, and so on and so forth, and all the way through. But we're making our for loop do that. So this is going to be kind of boring because if you see that, right, they're all just being drawn on top of each other. So why don't we do something like this where we say boxes.back and we say dot set position, and we could even set it random colors as well. I'm going to give it a random position. So in order to do that, I have to include stdlib, right? And I have to include time.h, sure. Okay. If you remember from the time 0 or something like that. I can't remember the code for doing random numbers, something like that. Okay, so I got to say rand percent 800, and here I'll just say 0, and close that there. So hopefully now I should be, yeah, do you see how they're kind of popping up all over the screen there? That's cool. The other thing I could do after I draw my box, or even before I draw my box, I could go boxes I like this, and I could say dot move. And I don't want to move them in the X direction, but I do want to move them down. So let's say maybe 5 pixels a frame, something like that. And now they should kind of all just slowly fall at their own pace. Pretty neat, eh? And right now I have 30 of them, 40 of them, so on and so forth. Eventually my computer will just slow down. I mean, the ones that are falling off the screen, I really should erase them out of my vector. But that's another topic for another day. It's not hard to do at all, but I don't want to make the video too long. Actually, now that I think about it, the lab is actually the lab asks you to erase them, so I'll show you how to erase them as well. What we'll do inside of this for loop is we'll say if, okay, and we'll go boxes I. This is how we check if the thing's going to be off the screen. Dot, notice how when I put dot, it shows me all the stuff I can do, because boxes I is just one box. So I'll say get position, right? And I want to check its Y position, and I want to know if it's ever greater than 600, which is the height of my screen, okay? If it is, I want to erase it. And the way to erase something out of a vector is, and this is something you couldn't do with an array, is you write the word erase, and it would be really nice just to write the number, the point I in there, okay? Because I want to erase, like if it's the 5th one that's on the screen, I want to erase the 5th one. But it doesn't quite work like that. The way vectors work is they work and they deal in memory addresses. So when I say erase 5, it doesn't know like 5 from what. So the way you work around that is you pass it the memory of the first one. So you write the word boxes.begin. Boxes.begin is the memory of the memory address of the first box in your vector. And boxes.end is the memory address of the last box in your vector. So if you write the word boxes.begin and then press +I, it knows to erase the thing 5 spots in the memory from the beginning of the vector. Kind of awkward, but watch what happens now. See how it's always kind of hovering around 12 or 13 boxes? That's because they're getting erased off the screen as they go. There's a little bit of a flicker there as they erase, and that has to do with the order, the fact that we're erasing them like inside of this, in between clear and display. I wonder if I move this if statement above the window.draw, I wonder if we get that little flicker. Let's see. No, it's gone. Okay. So we actually erase it. Yeah, it looks good. It's cool. So we actually erase it before we give it a chance to draw, and that stops that little flickering artifact from happening. So there you go. That is vectors. They're very useful. We use them a ton in grade 12 computers because we're making lots of shapes move around the screen. If you're going to have a bullet system in a game or something like that, it has to be in a vector because those bullets need to get launched on the fly. They need to delete after they land into something or go off the screen, and vectors are the great way to do that. Okay? So have a look at that lab, and I'll post a few more labs as we go. I don't think I'll do a final project in the course. If you want to do one, that would be cool. Can make a little game or something, but we're kind of getting down to crunch time here. So just work on the labs. I just want to make sure you have a good understanding when we get to grade 12, and I'm sure most of you will have that. And if not, then we'll do some review if you to start grade 12 off, because that's kind of a free form course where we just kind of work at things we're interested in. Okay, so we'll talk soon. Bye now.